here. This is a subject I've been interested in and following for quite some time, dating all the way back to school. And so I appreciate the opportunity to share some best practices. And in the interest of everyone's time, we'll go ahead and get started. So here's the agenda for today's talk. I'm hoping to be about 45 minutes or so, leaving time for questions and answers. The agenda is a little non-standard because the topic is a little non-standard. Because it's really dependent on workflow and needs and a lot of variables. So rather than trying to come up with a one-size-fits-all, we're going to cover it a little bit different. I'm going to start by defining what I see the problem being with this type of data, defining some terminology so that everyone's on the same page of what we're talking about. Then I'd like to propose an initial workflow that you could use and craft for yourself, and then provide some solution examples to help kind of show how some of this looks in a more practical sense. The real goal here is to try to make things easy. While this is not a technical training, we will cover some topics that are a little more technical in nature. So I'm going to start with the problem statement. And before I do that, I'd like to use a quote that I've used quite frequently over the last 10 years, and it goes a little something like this. There are known knowns. There are things we know that we know. There are known unknowns. That is to say, there are things that we know that we don't know. But there are also unknown unknowns. There are things we don't know that we don't know. You may or may not have heard that quote before. That's from Donald Rumsfeld in 2002. And when I first heard that quote, I thought it was rather strange, to be honest with you. But in data and GIS management, it's actually quite a nice quote and actually fits through very well. If you think about the first line there, it's basically saying we have constants. We know about those. The second line is that we have variables. And the third line is really, in my way of viewing it, we're trying to be extensible. We're trying to use workflows for things in the future to be practical and efficient. And sometimes we really don't know what those look like yet. So with that kind of in mind, the real true problem statement in my mind looks a little something like this. I want to find the most efficient way to handle or process data based on my known set of variables. And of course, that set of variables could be different for you. Generally speaking, there's maybe about a half a dozen. Here's some that I thought of off the top of my head. The first being data volume. When I say volume, I mean more the number of fields of data that I'm trying to transmit, not really the number of records. The type of processes we're talking about are quite fast, so hundreds or thousands or hundreds of thousands of records really aren't quite as important as how many different fields we're trying to transmit. Since we're talking about GIS, the geometric complexity of the data is also important, and we'll cover that in a little more detail. So is the frequency. In other words, how often am I trying to transfer data, and in what direction am I transferring it? Am I transferring it just out of the software, just into the software, or both? And then the database acronym CRUD, which stands for Create, Read, Update, and Delete. What am I trying to do with my data? Am I just creating it? Am I just reading it? Or do I even need delete type functionality? And then finally, again, extensibility. And I'm using that term to say, if I do something on a model now, is that something I'd like to save to be able to use on a completely different model, say in 6 months or a year from now? Those are all things that make a difference when I'm trying to decide how to handle and manipulate data in the software. So with that kind of basic problem statement in mind, let's discuss a little terminology before we get into the workflow. And this is basic terminology. It's beyond the scope of this Xpertorial to get into too much detail, but I do think that it's important that we're all talking about the same type of data. So let's start with a very basic database definition, and it's simple as an organized collection of data. I say relational data because there are lots of different flavors of database. We're going to be talking just the relational type. And even within that realm, there are two kind of subsets. The first is the embedded database, and if you've used Microsoft Access with an MDB extension, you've used an embedded database, or perhaps SQLite, or maybe even Apache OpenOffice. Those are all database that run self-contained inside your computer. There are also server-based databases, for instance MySQL, Postgre, or perhaps a Microsoft SQL Server. Those typically run on a server itself. There's also the flat file. So the flat file is one file, typically from a database. That might have an extension like DBF, a database file. It could be a comma-separated variable or a text file. The difference, of course, between a flat file and a database is a database, again, is a collection of different tables that are somehow related. Usually, to handle a database, you have a database management system, and typically they have the same name. So in other words, if I'm using Microsoft Access, I would use Microsoft Access to handle that database. This is a very simple, obviously, example of a database table. You can see it has columns. The headers there are ID, name, diameter, and roughness. Just again, a very simple database. In this case, ID is an integer and name might be text, and ID might be something called a key. In a very loose definition, if you're not that familiar with a database, would be Microsoft Excel. If you've used Excel before, you know that there can be multiple tabs. Each tab can be loosely thought of as a table, and the whole collection of the workbook as a database. To be able to actually do something with those different tables, you need some kind of key or something that compares the two or more variables across the tables, in this case ID. So I know that there's only one ID of the number 1, and it corresponds to something with the name of PL1234, hence the relational aspect of the database. But since we're talking about GIS, there's also databases with spatial awareness, and that's a very loose concept because the different databases have much different types of spatial awareness. And you may have heard them called a geodatabase, a spatial database, a GIS database. Again, if we take our concept of the database and add some spatial columns to them, we get a database that can be queried not only on, let's say, diameter, where I might ask the database, show me every line with a diameter greater than 48 inches, and it would return ID1 and any other rows of data. I might also be able to query that database and say, show me any line within 1 mile of a certain point, and it would be able to return responses there. A somewhat ubiquitous form that isn't a database but is a GIS in nature is the shapefile. So underneath my columns, you can see I've shown the 3 required shapefile extensions, the DBF, SHP, and SHX. You've probably seen the DBF file before. That's something you can open in a different database program or in Microsoft Access. And then the .shp is the actual geometry, and the SHX is more like an index file. Those are the 3 required. There are additional files that can be used to add additional data, make things run faster, show projections, etc. And then just like a database management system is used to be able to manipulate and interpret a database, there's typically some type of GIS, which is a system to manage that spatial data. So we have 2 databases, or spatial data and a database. The way that those speak together, one way, is the ODBC, which is an acronym that is the Open Database Connection, and it's just a protocol so that different databases can talk to each other. That's all I really want to cover. Again, that's just kind of the 30,000-foot view on terminology, but we're going to cover a lot of these in the workflow and the examples. So let's start, and I have tried to distill this down into 2 questions from a workflow standpoint. The first question is this: what kind of geometry do you expect to be using? And you see here I have the question, the polygon or polyline, and I have a little asterisk there. I'm about to give you my, for what it's worth, definition of what I would use as a decision point. Of course, your decision will change over time as you become more familiar with certain ways of doing things. And so if I have a polygon, potentially catchment or some type of polygon boundary, or a polyline that has more than 2 vertices, I'm going to say more than 12 vertices is a cutoff, but that's for your choice. So if I have complex geometry, I want to start with a shapefile because it's storing the geometry in an easier way. If I don't have complex geometry, I'm kind of leaving the choice open as to whether I should use a shapefile or some data connection. That's my first question. So let's assume for this workflow that we have selected a complex geometry. I kind of have 3 more questions that feed into the data aspects, and the 3 questions are: am I expecting to import or export that data often? Do I have several different fields to map? And is this something that I might be able to use for other models? So again, I would say more than 2 times as far as importing or exporting, and probably more than 5 fields. So if I have complex geometry and I plan to move the data often, I would use a shapefile for the geometry, and I would use a database for the data. If I'm not moving that often, I would probably just use a shapefile. Same question on the less complex geometry as far as the data. So if I have very simple geometry and I'm going to be moving that geometry in or out of XPSWM, I'd recommend the open database. If it's not going to happen very often, it's really personal preference. So if I show that on just one screen starting at the top middle, again the questions, complex geometry, and then how often am I moving my data, you can see that I can choose a shapefile for both data and geometry. I can choose a database or a flat file for both data and geometry, or I can actually split it up and I can use kind of the strengths of one and the strengths of another. So let's get into some more practical examples using that workflow. The first example is related to a flat file, and I kind of have this note at the bottom saying that as we get into more involved examples, there will be some code and some software and drivers utilized. Purpose here, I'd rather that everyone just kind of watch the implementation and worry less about trying to write down exactly how it's done. That's something that we can definitely provide, and I'll provide a link at the end where we'll put that once it's ready to be uploaded, which should be fairly soon. So with that in mind, just sit back and let's go through a couple more practical examples. So the first, again, is a flat file, which will be geometry and data. So I'm going to try to use a flat file to import both. I should mention that I'm using a pre-release version of XPSWM 2014, so there may be an odd warning or otherwise. I'll point out if that's something that's not in a production level. This is a slightly modified example from one of the Getting Started models, and I've started by highlighting a polylink that obviously has complex geometry, and by that I mean there are extra vertices in this. I want you to just remember the shape of that as we build on this first example, kind of the simplest of all the examples. So I'm going to start over from scratch, and I'm going to import in using just a database file, a .dbf file. There are two ways to do that. One way is through the import-export through file and then external database, because in fact that's what it is. A more direct way is just through tools and GIS link. You can see there's a persistent connection because this example had a node connection already established, which is a value. Every time I open this and hit import or export, it's already established. For the purposes of this one, I'm just going to import it and show you that there's a series of 34 different lines. I'll say OK, and you can see it created 34 nodes and read 68 variables. I'll hit close. Those are the same files that were there before. I'm now going to import the polylinks in a little slower to show you how that actually works. So if I go to GIS link, I'm going to start a new connection. Independent of whether I use a database or a flat file, this wizard looks roughly the same. So I'll start by selecting a file. You notice if I go in, I actually need to find a file that is a valid file. So I have my bad file example here. If it's not a correct file, I cannot move forward in this logic tree. So I have to pick something that is valid. So I'll pick this link file. You can see now it shows my connection info here, and I can produce or progress down through this tree. The next question is which table, because I can use Excel or otherwise. There may be several tabs or several different tables. In this example, I only have one, so I'll choose link. Then I can choose how I want this data to move. Do I want to just import it, just export it, or both? For this example, I'll keep it simple and just import the data. Next question is related to how I want to import the data. Do I want to just update existing objects, so existing polylines, or do I want to create and update them? Well, since I don't have any polylines now, I definitely want to be able to create them. Since I want to create them, the mandatory data will change. Again, I've selected link. Notice the other ones, I can do some global data and other objects. I've selected link. Since I want to generate a link, I need not only the name, but the upstream and downstream node. If I were to just want to update existing ones, I wouldn't need upstream and downstream because link in XPSWM is the primary key. That's all I would need to be able to correlate data. I will do create and update. So I have a link name, I have an upstream node, and I have a downstream node. Those are the mandatory fields, but of course I can provide as many fields as I'd like. So in this case, I might also want to map diameter. So I can go in through XPSWM and find diameter and map that. Similar to roughness, any other type of data I want. These are all input data. Certainly I could also map output data. And in this instance, let's say that my diameter in my external database was in feet, and I want, or in say inches, and I want it to be feet. That's certainly something I could change if I wanted to, or change from meters to feet. So definitely there is some changes on the fly of units if necessary. In my case, I have no change, so I'm just going to hit Finish, and then I'll hit Import. I hit Import. Again, it's showing me all the different data that's there. I hit OK. Notice that it created 32 links, but it read extra variables. So hit OK, I hit Close, and you can see that it's almost perfect. This line is straight because all I've defined is the upstream and downstream manhole, so it doesn't know that the geometry should be complex and bend around. If I do look at the line, I can see that all the data is there, so it's built everything the way I'd like it, but unfortunately the geometry is not there. And that's somewhat of a limitation, thus the initial workflow question of what does geometry look like. So let's look at bringing in geometry and data from a shapefile. It's a little more straightforward. Again, same type of beginning file. I'm going to delete that out. But as you probably know, if you go into links, you can right-click and just directly import from GIS. So if I'm to do that, and I go into my example, I can just pick the link shape. Right here, if I'd want to somehow filter that, for instance, only import links that have a diameter greater than 24, I could do that. But I plan to bring everything in. In fact, I can bring it in quite quickly if I let XP do its own default name and use the endpoints of the link, and I hit OK. You'll see here that it generated and read 32 rows of data. I'm getting some warnings because it had to build the upstream and downstream links, which is fine. But notice now that I had the entire geometry in about 5 seconds. Right? Now I could have gone through here when I imported, and I could have defined and mapped the fields like I had before. But that connection is not persistent. In other words, if I do that, even if I save it, if I come back in and I want to import or export, I have to rebuild my query, my connection string from scratch. But you notice here that the geometry looks exactly like I want it, but if I look at my conduit profile, everything's empty because all I have is a geometry. But again, it's very fast, and if I'm just building a model, that might be a great way to start and then use all the tools built into SWM to actually create and build the model and then perhaps export later. So a nice way to be able to kind of get the best of both worlds is to use the strengths of each one. So in this example, what we'll do is start from scratch. I'll start with the nodes in, and I'll now go in and import the links, very similar to what we did before. So I'll go to the files, and I'll find the link and import. I'll make a slight change. Now I want to actually use what I know to be the correct indexes from the data, and by that I mean the name. I don't want XPSWM to pick a default name. I'd like to use the name in the database, and I'll show you why in just a second. Similarly, I want to define the upstream node by its text upstream node, and same with downstream node. I'm not going to map the fields, but like I said, I could do that, but I'm not going to do that right now. I'm just going to go ahead and build that in, and now you see everything here, which is great. But because I use the built-in name upstream and downstream node, if I go into my GIS link and I have a database connection of link, I could hit import and use that connection. Notice I didn't create any new links or nodes, but I read 128 variables very quickly. So now I have not only the geometry I wanted, but if I look at this conduit profile, I have the data behind it as well. So that's a nice way, especially since typically speaking, the geometry, or the way that the file itself looks, doesn't change as often as the input data, and certainly doesn't change as often as the output data. So it may be a very valid workflow to use a shapefile or some other type of intermediate GIS file for geometry, and then use something like a database file for the data. It's really not a bad way to do things. There are a couple drawbacks to that, of course. One is I'm using 2 different files. Certainly I could use the attached database file from the shapefile, or I could use a different file, but those files aren't necessarily connected. And by that I mean if in XPSWM I were to change the name of a link and then try to do that same process, I'm going to get at least one warning or error because I don't have the connection I had before. And that's because I don't have a database. I don't have an organized collection of data. I have a loosely organized collection of data. That and many other reasons are why a database connection is quite nice. So the first one I'm going to do is a very simple embedded database, and I'm actually going to build it from scratch for two reasons. One, so you can see that it's not as complicated to do as you may have thought, and two, because the next example will be a little more complex. I'd like you to see that I'm just saving some time in the next example but doing some relatively straightforward work. So what I'm going to do is open up a very small little utility. This one is called SQLite Spy. There are many different ones. SQLite is an open source embedded database that last I looked had several 100 million installations. If you have an Android or iOS phone, you have SQLite databases in your phone. They're also really nice to be able to use to put data back and forth, not only from a mobile device, but also into more server-style systems like a Postgre or even a SQL Server. But let me build a new database, and actually what I'll do, just to make sure that we know that we have a new database, if you bear with me just a second, I'm going to delete the one that's in there, just so we can definitely start from scratch. So you can see this example 4 database. We'll delete that. So it's out now. So let's go ahead and rebuild that. I'm going to make a new database in the same area, and I'll call it example 4, just to keep things simple. And I'm going to create the tables that I know I need. And so I'm going to have a table called nodes, and I'm just going to put in basically the minimum requirements. Let me add one more just for interest's sake. So I built a table called nodes, and that table has some very simple fields in it: name, X, Y, and ground. Pretty straightforward. The other table I need is links for my example. So I have a name, I have an upstream manhole, and I have a downstream manhole. And then I could have something, let's say, like diameter. Okay, so now I have two tables that are built in here. One of the other benefits of these type of databases, even though they're embedded, is they're quite transactional. And I use that term to say that I can have it open in this piece of software here, and I can at the same time open it up over here in XPSWM, and I can also open it up in, say, a GIS. So I can handle everything quite well. So I will go in to my GIS link, and now we're going to venture down into the land of advanced. Don't let the advanced take you too by shock. It's really not that advanced. It's just a couple extra steps. And so if I choose advanced, I'm provided with this, and you may have seen this before, which is all the different database providers. A lot of these are built in from having a Windows computer and or also having Microsoft Office. Since I'm using SQLite, I had to download a different driver, and we'll provide a link to where that is should you care to use something like that. I would liken that to buying a new printer and installing it. It's just a protocol of a way the computer can talk to it. It's independent of XPSWM. It's how Windows itself needs to talk to this new data source. So when I go to next, I have to pick the data source. So that's the one extra step I need to do. And since I want to do this example from the very beginning to the end, I'm actually going to show you that. If you go over to Windows, you can find your ODBC data source by just typing in ODBC, and you'll see data sources here. Again, you'll notice Excel files, Access files. Those are all things built in because I have Microsoft Office on this computer. But I can also add this SQLite driver. And it's quite simple. All I do is give it a name, and I browse to that little file I just created. And it happens to be right here. So if I look at the configure, I called it example 4, and it happens to be located right there. And it's called ex4.db. Lots of options that you could choose, but for my example, it's as simple as that. Once I hit OK, that data source is available not only to XPSWM, but to Microsoft Excel or Access or any other file that uses an ODBC. And there are many that do that. But now I'll pick that example 4, and I can actually test the connection, and you see that I've connected. So I'm currently connected to this little database through this little utility and through XPSWM. Now that I've done that extra 2 steps, it's just like before. So I pick a table. Let me make sure I get the right table. Bear with me just a second. Sometimes it seems like everything will work, and no. And maybe it doesn't. It's the first time for everything. It's always, I should have mentioned this at the beginning, The more often that you try to do something like this, it turns out quite well, and then you do it one more time, and on the 10th time it doesn't work. Let's try one more time and make sure I've browsed the correct spot. Aha, I think I know what it might be. We'll bear with me again. We'll try that and see if we connect in. I will give myself, I'm nothing if not slightly stubborn, so give me just 1 second to see if I can't recreate that, and I'll actually do it even better. I will do it as I'll try even better like that. Similar to before, I'm not timing myself to see if I'm doing any faster. I hope a little bit faster. We'll have to see. And if we're lucky, we have 2 tables there, and I'm now going to, I don't need to save that, although it could definitely stay open. I'm going to add a new one just to make sure there's no question about what's happening, and I'm going to browse to, well, the one that I hope actually will work. Example 4, and I'll call it B just so I can see it. I hit OK. So when I go here, let's see if we get lucky and that example works. The connection test, let's hope that we actually have some tables in it. We'll just have to see. There they are. So let's go into nodes, and we'll go through this a little quick because of that slowdown. For now, we can say import and export, right? And so just for interest's sake, we'll make it create and read. And so I had name, X, and Y. I'm going to go ahead and map those fields here as well. Now you may ask, why do I have to map it once in node and link and then once in mapping? It has to do with whether you're reading it strictly for generating the geometry or you're actually writing it to the database. I typically write it there anyway. You'll get some warning messages because that's something that can't be overwritten, but it's worth it when you're trying to build geometry. So let's go back here and add links. Similarly, I'm going to kind of step through this quickly because we basically did this through the other examples, but just showing you kind of the full-on from start to finish. And so we'll write upstream and downstream manhole, and say, and then again, just really quickly, we'll give just the upstream and downstream. Let's see. We'll hit finish. And so let me close that. There's nothing to import or export, but I can add some files here. And now when I go into the GIS link, I could certainly export that. It says I've created 8 objects, and if I go to links, I can export that. I created 4 objects. Let me go back to my little utility here and see if I can't open that same little database and show you the data. And really the benefit here is, one, let's see, I can see down here there's a little plus sign, so the data is definitely there. So you can see the data. I have name, upstream and downstream manhole. Those are files I received from XPSWMM. And you can see name there. And so certainly I can, if I wanted to, I could change data in this aspect here and then import it back in, vice versa. So I could also, if I wanted to, I could add a new record here and then bring it back in. A quite simple example, this one is stronger on the data. You can see the X and Y field here, and it's quite easy to look at, but most spatial databases don't treat geometry as something that you can see. We don't treat it encoded that way. Typically it's encoded and presented and stored as a binary object, and which is not a lot of fun to look at through anything other than a program designed to look at it. So certainly there are GIS systems in the world that can encode that delimited text pretty much on the fly to show you points. It gets a little more complex with lines, but it's possible. But I do want to show you this example because it can be quite useful. One, you can also use it as a way to store a lot of different data. So we didn't really cover this, and I won't cover it too much just due to time here. But certainly you have a GIS kind of gateway, for lack of a better term, inside XP tables. And so you could go in and pick a shapefile or map info file and map it. And kind of as a pro tip, I suppose, I'm sure you've seen the limits. This is something that is independent of XPSWM, but as the spec on the shapefile of the field name. So you probably had to go through before and type depth and type and pattern. And then if you hit export and you come back, you have to redo that. A nice way, an alternate way to do that, especially if, like a lot of us, you have a table and you really like the way it looks, is to copy that table and then prepend or append GIS to it and put the headings in here as you want them. So you could format that to be what you want it to be called, and then it is persistent. So every time you had it and you selected and filtered the way you want, you could just dump it to a shapefile. Perhaps the most useful way to handle a database is with another utility that, again, apologize for time, but I do have some working examples if you have interest, which is running the interface utilities. And so my background is more in sanitary. So let's say I had a large model that ran for a week, and I wanted to know the amount of time that the flow in the link had flow, but the velocity was less than 2 feet per second. Well, most of the statistics in XP tables are summary statistics. The interface utilities will let you write to different encodings a flat file of all the data for every time step. That's something that you can quite easily bring into something like SQLite or Access quite directly, do your performance work, generate new tables, and then, as you might expect, be able to bring that back into XPSWM. So those are two ways that, if we had time, I could cover it, but again, if you have interest in that, there's some pretty straightaway ways to do that. So to me, the biggest downfall so far in this example, and there's only one more left, is related to the fact that I can kind of see the geometry, but running it through a GIS is going to be a little bit more complex, especially if the GIS is generating binary data. How do I get that back into XPSWM? And so I want to show you one last example there. And the last example, I'm going to even title advanced. It's really inappropriate to call it that. I think it would be better called just spatially enabled. It's somewhat advanced, but it's really not that bad. Let's see if I can get it clicked on. All right. So you can see I don't have much to start with, and that's by design, because I built this last example as a way to hopefully lower down the barrier that some people have with interfacing XP directly to GIS data. So I wanted to make something quite extensible, and so you can see that I have a database connection set up for something that actually is not built yet. But what I want to do is I'm going to close this, and I'm going to open another example from the Getting Started. And so if I go down to Getting Started, so if you go into Getting Started in folder 8, you'll see this example. What I'm going to do is actually merge that file I had before. So I'm going to merge that. So I'm going to go back over to where I was, and I'm going to merge this little file here, which is basically just an ODBC connection. I merge it. We do a few things to make it clean up a little bit, and basically I have not affected anything with the objects in here, but if I go into Tools, GIS Link, there are my database connections. So I can basically apply that previous XP file to any file I'd like to be able to quickly start working with the data. When I built the old version successfully the second time, I told you I was doing that mostly that I could kind of run through something faster here. And so what I'm going to do is run through an example that's going to build something with a little more meat on the bones. And so rather than you watching me type it out, I'm just going to automate that. One extra thing I'm going to do, because I do want this to be spatially enabled, is I want to use the SRID. And if you use Esri, you may have heard that with the acronym FIPS, F-I-P-S. There's lots of different terminology, or EPSG. If you're new to the GIS world, there are quite a few acronyms that you may have to learn or may not. Basically, this is a unique identifier of where I am in the world based on the projection. As something that could be useful, there's a site called spatialreference.org. That's a great site if you know a little bit of information about your PRJ file, whatever your file is. In this instance, I know that I'm in Australia and I'm in zone 54, so if I type in a little bit of information, I can see that I'm number 20254. I only mention that as just a nice reference if you're trying to figure out where something is. And so this is going to build a file. Certainly knowing where it is not necessary to build a file. It is only necessary if you want to export and reproject data. So what you're seeing here is just a few different shell commands to build a database. And I'll show you what that looks like after we put something in it. So now I'm going to go to my GIS link, and I'm going to export these geo nodes, so 154 nodes. I'll export these geo links. I did not tune this to be incredibly fast. I'm sure the queries could be sped up just a little bit. In this case, you can see it hanging just for a second as another tip if you do this enough, independent of the platform. Certainly, if you're checking the database, it is still inserting rows dutifully into it. Microsoft at times has a way of just bogging down, but Windows itself is waiting, but it will in fact generate all the data. You can see there 154, and we'll talk about why it's that slow in just a second. I personally like to keep things simple, so through your configuration you can launch any application from SWM, so I like to launch my GIS from SWM. Personally, there's a lot of utility in QGIS. Certainly Esri has the ability to read. This is a Spatially database, which is basically a SQLite database with some spatial enablements. If you have ArcMap 10.2, then you have direct ability to read this. If you have pretty much any version of QGIS, you should be able to read it. If you have something less than 10.2, you could read this with just a little bit of Python work. Again, beyond the scope of how to add that data in a GIS, but I will add it. And if you see I connect to the database, you see there are 4 different tables here, links, nodes, and some archives. And we'll talk about that in a second. I'm going to add those. And just for interest's sake, I'm going to go ahead and style those so they look similar to what is in XPSWM. Let me pick the right one. Okay. So if I look at that, it looks very similar. So that was just built just now. And if I look over at XPSWM, it looks very similar, or as similar as I cared to make it look. And I will also launch, just for interest's sake, a different viewer. So this is Spatially. This is a graphical viewer to view SQLite databases that have some spatial background to it. It's a little standalone. It's a GIS in its own right. In fact, if you look at GeoLinks, which is what I just exported, actually you can do things as simple as view the map, what it looks like directly from this little user interface. This is a standalone executable, probably on the order of 10 megs. And you can do all the same kind of queries here. A lot of people, even though this is somewhat graphical, would prefer to use something like a GIS. So let's talk about this connection and what we can do. I've kind of skipped over the fact that we could have written extra fields to this. In other words, I could have written more input or output data, but I think once you see that it wrote a little bit, you can see that it could do anything I needed it to do. So a common workflow might be new data generated in my GIS. And so I have a new point here. Perhaps I have an invert and ground data. That's not required, so I won't enter it. Let's have a new point, maybe up here. Maybe I do have that. So maybe I have an invert of 100 and a ground of 120. And let's say I want to add some links to connect those. I'm going to add a line from here to here, and I'll call it line 1, and I'll give it a diameter. Notice how little information I actually have to give it to be able to generate that. It's kind of the value of a spatial database. Line 2, and then say a diameter of 1.1. As a nice general concept, it's useful to export nodes first and then export links. And similarly, it's useful to save nodes first and then save links. That's just something that is a good rule of thumb, just because generally this defines itself based on where it is. I have these 2 lines here. Another thing you may have noticed is I didn't actually snap the lines to the endpoints. That's something I could have done, but I chose not to, because the database can actually find the closest location based on the fact that it has spatial awareness. Let's go back over here and import those back in. So I go to link and I hit import. I'm going to get a bunch of warning messages, and that's okay. The warning is telling me that certain fields, like X, are not things that I can overwrite in my mapping, and that's not something I want to overwrite, but it's letting me know that. Same with links. So I'll hit import. I'll get the same warning message. Not a problem, though. And I'll have 2 created. If I hit close, you'll see the lines are there. And unlike in the previous example on the GIS, these are actually snapped together because they're defined to be snapped together. So what may happen as another workflow is potentially I don't need to change more data, although I could certainly build something else here, but perhaps I'm doing something like moving the data. So now I haven't done anything but change the location of where it is. That's something where I can go back out and export. And you see I haven't created anything new because there's no new names. I've only moved things. I'll go ahead and do that even though it's not really necessary. You'll see it runs faster on an update than it does on an insert. And if I come back over to QGIS, I actually don't even have to refresh anything. Once it's done, it will actually just show itself. So if I click on it, you see it's moved. I mentioned way back before at the beginning that XP uses the name as its unique identifier, so something that happens from time to time. And the reason that this export is slower is I've added a little extra utility here. So perhaps we don't want to call that new P1. Perhaps it has a similar identifier. Maybe this is some kind of asset identifier and it has now been accepted into the system. So it's no longer a modeled line, it's an actual physical line. I want to change the node to indicate that. Well, I'm going to get a warning message when I do that. I hit export. XPSWM is going to tell me something that I need to know, which is that that used to be called new point 1 in this other database. Now I can't find it. And that's what I'd expect. I'll go ahead and hit export. Again, that's just what I like to do, just to make sure everything is the same. So you notice here that it's actually put in two different lines. So I see that there is a node of my new point 1 and also a node of my numbered line there. There are ways, different ways you could choose to handle that. I had built in here these archives which would take that and delete it and move it into an old system, or you could keep it, or you could manually go in here and delete it. Really your choice. The final thing that I think comes up often is, especially in the world of sanitary sewer, perhaps I have a force main, and so I have a complex polylink that has more than two vertices. In other words, a vertex exists in between my two lines. That's something that I can handle here. So let's say this example, this rising main, actually is a force main. So let's say it looks something like that. I'll hit save, and you can see I have this little bend in there. So as you'd expect, if I come back into XPSWM and import that, that won't show up, right? Because there's no way, based on the database, to be able to handle that. But just to prove it, I'll hit OK, and I'll get all my warnings to say that I'm not going to be updating fields, just like I don't want it to. I'll hit import, and you can see, I'll mention something here. You notice because I exported a new one and brought it back in, it actually created that second node, right? It created that line, even though that line wasn't there. That gets back into what we talked about with CRUD, create, read, update, and delete. It's a pretty good and standardized way that we're not going to be able to remotely delete out of the external database without building in some kind of trigger to do that. But let's do one other thing. Let's show two things. I want to show you the power of this type of database, this database here, and that is that I can quite easily take that kind of data and dump it into something, many people like KML, which is Google Earth. Well, since I originally defined this as a map grid, I can easily convert that into latitude and longitude. And so you can see it shows up here, including a little bend. So there's the bend that we saw before. To make it easier to see, I'll go ahead and add the nodes. It generated this in about half a second, all this data. Also, although just for interest's sake, you could certainly generate that as a shapefile or a map info file. You also notice I have this vertices.xpx. If I look at that file, that's just dumping a table. There's a command vertex start and vertex end, which is something that inserts vertices. So as you can imagine, if I go back into XPSWM and I import that data, this is kind of why I said before that I was going to have all this as an example, so you didn't have to try to follow directly along. Just more of if this is something that might be useful. There's vertices. I'll hit OK. I'll get the warning that says I might be overwriting something, and you'll see that I just put that bend in there. That would work for as many bends as I wanted to, within reason. I believe I set this up for table views up to 6 vertices. Up to 6 vertices, it'll work fine. Certainly you could extend that beyond, although generally speaking, 6 or say 12 vertices are probably enough. One last thing I wanted to touch on that's useful. A lot of people, I feel like, really like GIS because of the raster, so the background image. This is all vector data, points, lines, polygons. A lot of people like the background image. A lot of people like Esri or QGIS because it has the ability to view a web map service or a tile map service. But there are ways to take that kind of data directly into something like XPSWM. So I'll show you an example here, and this is something that's just a one line, but I'll pull it up. So this is a raster. Now it looks a little better, right? This looks a little more like a lot of people are used to seeing with a GIS. But what I can do is save that in QGIS, and I can save it to, again, 20254. If you recall, that's where we want to be. So if I go into my documents and over to, I'm just going to place this somewhere where I can find it. I could really put it anywhere, but I'll make a file called background. And I'm going to make it to the map view extent, and if you'll allow me, I'm going to make it a fairly rough resolution. If you notice, it could be up to 10 times better than that, but just for the interest of time, I'm going to have it be quite ugly, to be frank, but to run quite quickly, hopefully. So let's run it. I'm going to do one last thing, and that is on this raster, I'm going to extract what I just built. So if I go up to, let's see, and there's my background. If I hit open, I like to generate that projection file too. It's a useful, well-known text version. If I do that, it has created it. In this instance, it does it in a slightly not standard way. So if you'll allow me to just rename this to what we're most used to, which is the world file for a TIFF.tfw. That's all I really need to do. So if I go into background images, I can add that image I just created. If I go into Files, GIS, there it is, background image, and I hit OK. And I hit go, there it is. It's projected to the Australian map grid zone 55, even though the original projection, of course, as a tile or web map service, this is actually a web feature service, is not in that. It's in a geographic projection. That's just a quick, kind of at the end of the talk, the way to show you how to quickly get a background raster in. Again, if I were to zoom in, you'd see that it's quite poor resolution, but that's not to say it has to be, just because I was trying to do it quickly. Now, they look pretty good. They look pretty similar to each other. So that example is, again, more of a spatial example. Of course, it could also be handling a lot of export data from XPSWM, output data, perhaps max water surface, things like that. So let me summarize, because I'm running up on my 45 minutes I allowed myself. The right tools really depend on the right problems. That last example isn't necessarily any better than the first example, just depends on what we're trying to do. So if we really just have data we need quickly and we're building maybe a one-off model, there's no reason to really build a standalone database to do that. The right problems now aren't always the right problems later. So I do like using systems to work towards this, because you have the benefit of having something standardized to start with, as well as to be able to continue to improve upon it. The example we just looked at is something I built just for this talk, so it really hasn't been that well vetted. But over time, I'm sure it could be developed into something that could handle pretty much any projection in any workflow process. There are tools provided in XPSWM to meet most problem requirements, whether it's the background image or import or output of data. And hopefully, this helped you see some different ways to do that, and some workflows that might make it a little bit easier. That's all I have right now, and I appreciate the time. And that's the end of what I have prepared. Thank you.